everyone. Thank you for joining us for day one of the two-day third annual HPC AI Advisory Council UK conference. My name is Brian Sparks, and I'm the Director of Worldwide Operations for the Council and will be today's moderator. I'd like to take a quick moment to thank everyone at DRAC STFC for their partnership and support of this conference and for helping with the Council's mission and learning objectives. I'd also like to thank our media partners, HPC Wire, Inside HPC, Next Platform, and Scientific Computing for their ongoing coverage of the Council's worldwide conferences and activities. Obviously, we would have loved to do this conference in person, but we're happy to be able to bring this to you live over the web. During these times, we hope everyone is safe and continue to remain healthy. For the next 3.5 hours, we have a very robust agenda with some great topics and speakers. I encourage everyone to ask questions via the Q&A window, and our presenters will try to answer them after their presentation. This webinar is being recorded and the sessions will be made publicly available, including the slides which will be available on the Council's UK conference website over the coming days. With that, let me introduce you all to Gilad Shainer, Chairman of the HPC Advisory Council. Gilad, good morning, good day, welcome, you have the floor.
Yeah, thank you, Brian. Thank you, Brian. It's definitely morning somewhere, no doubt about that. Thank you very much for the opening. We did prepare just a few slides to start with. And let me just put them on. Okay. I assume that you can see my slide, right?
Yes, I can, Gilad.
Thank you, Brian, for the confirmation. So welcome everyone to the HPCI Advisory Council and DRAC, the 2021 UK conference. We did hope, or at least I hoped, that we would be able to do this one physically in the UK. Unfortunately, we could not do that, obviously, because of the situation. We do hope that actually next year we'll be able to. And there are good signs. We are seeing some conferences they're getting back to a hybrid mode, physical mode towards the end of the year and for next year. So we do hope that for next year we can all meet in the UK at this time frame. I want to greatly appreciate the support from the DRAC side, working together to bring this conference and to host interesting topics, interesting discussions. Our mission is to expose everyone that is interested in the high performance computing world to more information, different usage models, market change, different kind of development activities, what's happening in different places around the world, foster the discussion and so forth. So 3 days, as Brian said, 3.5 hours per day, trying to pack as much as possible. I'm looking forward for definitely for the topics today and definitely for tomorrow. I think we're covering a broad range and very interesting topics. Agenda for tomorrow start the same time. We'll have a keynote from Paul to talk about the Open Exascale Lab in University of Cambridge, and Dika Panda to continue and having discussions on the development of communication frameworks, stick on Stack HPC and so forth. So all the topics are you can have them on the agenda side of things, of course. A little bit about the council, just a quick one. Established in 2008 with the mission to foster HPC knowledge education, collaborations, development around the world. We continue to grow. We're getting close, I think, to 450 member companies, universities, or research centers, which are part of the council. My only job within the council is essentially try to put all the logos on one slide. So I still have some empty spots, so that means I can keep my job for probably 2 more years, give or take. Some of the things that we're doing might be of an interest. So first, we do operate a small HPC center that hosts different kind of systems, machines that includes different kind of technologies. those systems are being used by the council members to develop or explore and publish our best practices around applications, setting, performance optimizations, and so forth. So we're doing a lot of best practices, and we're using those systems to build those best practices and publish them on the website. We also enable free access to the different systems, to the different elements there for members of the council that want to do their own testing, their own development, their own qualification, their own explorations, and so forth. And we do thank the members that actually help and contribute those components over the years and keep us be able to, or let us to enable us to actually bring these amazing collections of different kind of technologies together. On best practices, we continue to explore different applications, different workloads, taking things that we've done in the past and then run them again on new frameworks, new software frameworks, new hardware platforms, and so forth. And we publish everything on the website, from profiling of the applications to performance numbers and what's the effect of different components on the performance and ways to optimize efficiencies and so forth. Encourage you to check the website. We did a couple of refresh ones on Rely and Look, which now available on the website. Another thing which we take great pride of is managing student cluster competitions around the world and supporting other activities. So we are managing the World ISC Student Cluster Competition. There is a call for proposals, obviously, that will be closed towards supercomputing. We will be making an announcement probably early December on the teams. We had 2 years of virtual. After many years of physical competition, we had to move to do a virtual competition. Next year, we're going to go and do a hybrid. So the competition will include testing on a couple of supercomputers around the world, including the system in Toronto and a system in the US. As well, some of the teams, some of the European team actually would be able to go and participate on site, run the physical part of the competition, and we'll do it in Hamburg as part of ISC 2022. We're also running competitions in APAC, as well as workshops around different kind of programming languages, courses and educations, as well as we are participating in the summer school in Stanford. Again, happy to participate. It's helped to build and foster the next generation of researchers and scientists and professionals. So we're helping with the competitions that give real experience, as well with academic courses around the world. Moving forward, we're going to have a couple of 2 conferences later this year as part of the HPC China Conference and Supercomputing China Conference later this month in November. And then looking forward for beginning of next year, which will start in conference in Japan. Swiss conference is planned to be a physical conference. And we plan to move to hopefully hybrid mode or physical mode next year. And of course, continue with the competitions. So with that, first, I want to thank you from my side. Of course, hope that you're gonna enjoy the next the sessions today, and of course the session tomorrow. And I also want to thank our partner in crime, Mark Wilkinson, and the rest of the Musketeers for the working with us to bring this conference to reality. Thank you very much, and wish you great sessions. By the way, feel free to ask questions throughout using chat or any other means. We want to enable as much as discussions, of course, throughout the next 2 days. Thank you very much.
Thanks, Gilad. So now let's introduce Mark Wilkinson, who's the director of SDFC DREC. Mark, thank you again for all of your assistance and help bringing this on. Appreciate having you here.
Thank you very much. I'll share my screen. Can you see my slides?
I can.
Excellent. So, good afternoon, everyone. Thanks for the introduction, Brian, and yeah, thank you for the welcome, Gilad. So, I'm Mark Wilkinson from University of Leicester, director of the DREC facility. And so, first of all, it's a great pleasure to welcome you virtually to Leicester. As Gilad said, I hope we will be back to face-to-face versions of this conference next year. So I'm delighted. DREC is very pleased to be part of this network of conferences. And so I'm very grateful to the HPC AI Advisory Council for inviting us to be part of supporting this UK conference each year. I'll just mention that the image on the screen is the central admin building of the University of Leicester, and just flagging up that it is our centenary year. So the university was founded in 1921 as a living memorial to those who had died in the First World War. And so the motto for the year is celebrating 100 years of change. Obviously, there's been a lot of change in 100 years, and particularly in the last 18 months, things have changed a lot. And in terms of HPC, obviously things are completely different, and the next few years promise to be really exciting. And so that's it's a great time to be having a meeting focused on discussing some of those challenges and opportunities. So I'll just briefly talk about our news from the DREC community, which is that we've just deployed our new DREC 3 phase 1 hardware. So DREC, just to introduce us, we're the national HPC facility for theoretical astrophysics, particle physics, cosmology, and nuclear physics in the UK. And the process that we use to get from to get to the point of deploying systems, in the case of DREC 3, began many years ago. And we always start from the science case, so get the community writes down what it is that they want to achieve over the coming years. That then is peer reviewed, and then we go through an activity of translating those science cases into types of workflow and work out at a high level, in a technical case, what the general shape and scale of the services that DREC provides needs to be. That technical case is then peer reviewed. And after that, we work very hard with our industry partners to actually come up with service specifications at a detailed level, which we then procure and deploy. So it takes a long time and it takes a lot of effort, but I think we've demonstrated now in multiple iterations of DREC that this approach works really well in terms of delivering really performance systems and very competitive systems. So the funding that we've just spent was £20 million in capital that we were awarded in July last year from the UKRI World Class Laboratories Fund. The aim of the funding stream was to provide critical investment to maintain and upgrade equipment and facilities. So it was essentially to allow national facilities that urgently needed upgrading, such as DREC, to proceed with that even in a challenging year. So that precipitated a huge effort across all the DREC teams to get the systems designed, procured, and built in time. And I'd pay tribute to many colleagues in the technical support teams, in the software engineering team, and in the management of DREC, that everybody was basically pulling together to get this done. we engaged in a lot of co-design work with our industry partners, and that has really paid off in terms of the systems that have been delivered. And I'm pleased, I'm pleased to say that the live services have now are now starting in October. Now, the range of science cases that we, science workflows that we support within DIRAC means that we need heterogeneous architectures. So that's kind of the theme of this meeting. So we've got three services, the extreme scaling service at Edinburgh called TURSA. This is an Atos system. And so these are the new DIRAC 3 systems, I should say, that are all just been deployed. So the Edinburgh system is an Atos system. It's based around NVIDIA A100 GPUs, and the design focus there was large lattice quantum chromodynamic simulations, so theoretical particle physics calculations. And a key feature of the design is that each of the GPUs, there's 4 GPUs per node, but there's also 4 network cards. So there's 4, each GPU has its own route onto the network. And it's that connectivity which is required to deliver the performance in lattice QCD calculations. At Leicester and Cambridge, we have a joint service, the data intensive service. And at Leicester, that was provided by Hewlett Packard. And it is an AMD-based CPU system. In Cambridge, it was supplied by Dell, and it's a heterogeneous system, which is a mix of Intel Ice Lake CPUs and NVIDIA A100 GPUs. And the reason for having this heterogeneity within one service is because data intensive is supporting a range of different workflows and various complex simulation and modeling workflows. And the third service is the memory intensive service. This is COSMA 8 at Durham. This was supplied by Dell, and it's also an AMD CPU-based system, but with 1 terabyte of RAM per node. So it gives a total RAM footprint of 360 terabytes, and that's required to support its design case, which is large-scale cosmological simulations. And another key feature of that system is having a large flash volume, which allows very fast checkpointing. So from the tests that have been done over the summer, we've been able to checkpoint 320 terabytes of RAM in 7 minutes, which is a really fantastic outcome, and means that simulations can proceed much more quickly. Just to give one, there's many things I could talk about in terms of what's going to come out. I'll just focus on this one slide of one of the science results that we're expecting. So this is a run called Flamingo. It is a set of it's a cosmological simulation. It's currently running on the memory intensive system in Durham, and it's the largest ever cosmological hydrodynamic simulation that will reach redshift 0. So redshift 0 being the present day. It is aiming to, it's using the latest cosmological data from the Dark Energy Survey as its starting point. And on the right-hand side, you have a map not from the actual one that's running right now, but a slightly smaller test run that was done earlier in the summer. And this is a map of what will be seen by the eROSITA detectors. The full-scale run, which is still ongoing, has 400 billion particles. It's running on about 41,000 cores, and it has 320 terabytes of RAM. That's its footprint. So that's where we know the performance that we're getting from the system in terms of checkpointing. So this will be obviously very excited to see the result of this, but we're getting equally exciting results on all of the systems because of the phenomenal performance we're able to get out of them. Just moving on from the science, which is obviously at the heart of what DIRAC does, where the other key aspect of DIRAC's work is the twin aspects of innovation and training. And an area where those two come together is in our innovation placement program. It's a key pillar of the training portfolio that DIRAC offers, and it comprises 6-month placements for PhD students and early career postdocs. And the placements can be with industry or with other partners. So it's very, very open who can host a placement. We've been able to support 12 up to this point from a mixture of funding sources, but it was kicked off by an award from STFC, which funded the initial 8. And the partners who've been involved up to this point are shown here on this slide. In the coming year, we're delighted to have funding that we can now offer at least another 13 placements. 3 of those are funded by a combination of funds from partners such as including Hewlett Packard and Dell. And we're very grateful to those partners for their contributions there. And we also have 10 placements which will be supported by the Dirac Federation project, which is funding from UKRI's Digital Research Infrastructure funding line. And if anyone on this call has an idea for a potential partner, if you are a company or an organization who would like to host one of these placements, please get in touch, because we're always open to new placement partners, and we'd be very happy to talk to you. The benefits of these include bidirectional knowledge exchange, and that is genuinely bidirectional. So what I mean by that is we make sure all the projects are of genuine mutual interest to both sides. So it means that there's buy-in from both sides, and so we're able to ensure that there's learning going in both directions. For the people who take part in the placements, it's good for their careers in terms of skills development and employability, and it gives PhD students and postdocs, many of whom will be going out into the wider economy in the future. It gives them experience of working outside a purely academic environment. So this program, I hope, will continue into the future. So if you have ideas, do get in touch. Sorry. So moving to the final slide, just talking about the topic of this conference in particular. So the theme that we were building the agenda around was heterogeneous computing challenges and opportunities. And I think there's a great set of speakers over the next 2 days covering a large fraction of the key challenges and opportunities that we see in this area. I've listed some of them here, and I won't map them to individual talks, but I'll leave you to do that, an exercise for the audience. So on the hardware side, obviously there's a lot going on as we move into as exascale systems are being deployed. There's a lot of new technologies in all aspects of HPC systems, and so making the right decisions of what to look at and what to buy is going to be extremely important over the coming years. On the software side, obviously there's application software which needs developing. There's the middleware. We'll hear about cloud native deployments during the next couple of days. And there's also the software and system design actually need to be done in conjunction with each other. So that's something that we've always done within Dirac, and we're working with other partners to encourage that to become more a fundamental part of how the UKRI systems are designed as well. Co-design and partnership approaches are really valuable in terms of being able to deliver highly performant systems. And so we found it very valuable within Dirac to be able to take our workflows and real applications and run these on the hardware that we're thinking of procuring, and making our decisions based on the data that we see from running our codes on the new hardware. That's very important, especially as they become more complex in terms of the variety of hardware that we could buy. A key challenge and opportunity, I think, is in the area of people. So obviously we need training for users to help them to navigate the new hardware that's coming out, but we also need to be improving recruitment, our ability to recruit for people to support the highly skilled people to support all aspects of large scale computing and AI. One aspect of that, just to flag, is we need funding and career path development for software engineers, ResOps, DevOps, and I meant to actually add in data stewards. So as well as technical support posts, we need to actually develop ways for people to get into these kind of careers and to make it into an actual career path. And that's a challenge which definitely has to be sorted out. Obviously, all of this is also done in the context of needing to deliver net zero and to become more sustainable. And so that's, again, a challenge over the coming years to make sure that we're able to make large-scale computing facilities as sustainable as possible. So I hope that all of these challenges, in the UK, for those of you in the UK, you'll know there's a spending review at the end of this month where we're hoping that there will be funding released to start developing the digital research infrastructure at scale for UKRI. And so hopefully the funding will be commensurate with the scale of both the challenges and the opportunities. And so I would hope that we will have positive news in the near future. And so I just end by saying, just to give an advert for next year's conference, which, as Gilad said, we hope will be face-to-face. And if it's face-to-face, it should be back in the College Course Conference Centre at Leicester, which is shown here. So with that, I'll just say I wish you all a very productive and interesting 2 days. I'm really looking forward to hearing all the talks that are coming up. If you'd like to get in touch, our Twitter and LinkedIn handles are at the bottom. And I will hand back now to Brian. Thank you very much.
Thank you, Mark. And a pleasure bringing this on with you, and definitely appreciate the support. Looking forward to doing this in person next year. Pretty confident that will happen.